We have already done many experiments using expeyes, where the voltage measurement capabilities of expeyes has been utilized. But one of the strong features of expeyes is accurate time interval measurements. That means, if you give a voltage signal, it can measure the time between voltage transitions very accurately. So, we will try to explore this by using an oscillator circuit. Here if you see, we have kept a small circuit here, that is using an IC 555 IC, oscillator IC, and it is powered by digital output. You can see the 5-volt supply is coming here and the ground is connected, and the output is connected to our voltage measurement point in 1. So, we will try to study this output using expeyes. So, looking at the screen, you can see there is in 1 is now assigned to channel 1, but there is no output. Let us set OD1 high. So, that means the 555 IC is powered. Here you can see the output of this oscillator, and if I change this, turn this knob, you will see the frequency of that is changing. It is controlled by a potentiometer here. So, what are the things we can study from this? Like we see the shape of the oscillations, like the output, how it looks like, and you can see that it is not symmetric, like the high time is more than the low time. See, it is high for this much duration, but low only for this much. So, one parameter to be measured is the duty cycle, that is the ratio of the high time with the total time period. So, go to in1 and right click on in1. It says the frequency is say 1078 hertz and the duty cycle is 68.5%. This is possible because this unit can measure the time intervals, like say a rising edge here and a falling edge is here. So, what is the time interval between these two edges can be measured with microsecond resolution. And if you really want to do that by giving some commands, it is possible to enter that in this window. If I type R to F time and 3,3, that 3 means actually the input in 1. If you see on the box, there will be the number 3 will be marked, that is channel number of in 1, and it says that time, the rising edge to falling edge is 638 microseconds. Similarly, you can measure the rising edge to falling edge, and from these parameters you can calculate the frequency as well as the duty cycle. Now, this can be extended further, like this time measurement capability is not just measuring the electrical signals. The same thing can be utilized, suppose if you want to measure the time period of a pendulum. So, we will see how to do that. Like we have a pendulum that oscillates, like here I have a pendulum, you can see here it is say a pendulum here, a T shaped thing, and if you can put it on a knife edge and it can be oscillated. I will put it on a stand. See here you can see that, see pendulum is kept on this stand and it can oscillate like this. So, now the question is, how do we measure this time period? So, the easiest way is you generate an electrical signal from this oscillations, and how that can be done? What we will do is, we have one LED here on one side and on the other side we have a phototransistor. So, when the pendulum is oscillating, whenever it intercepts the light, the phototransistor can sense and generate a voltage transition. So, that is what we will try to utilize. So, let us make the connections, like the ground, both of these grounds, like the LED as well as phototransistor emitter is connected to ground, and now we should have some way of powering the LED. So, the LED should be powered. We can connect it to our square 1 output that will power the LED. So, we just connect that to the square 1 output, and now the only thing left is the collector of the phototransistor, and that is connected to the sensor input. As you know, this sensor input can measure resistance. So, now we have made the connections and keep the pendulum here, it can oscillate. Now, from the experiments menu, let us select say rod pendulum. So, it pops up a window like this, and you can set how many trials, how many times you want to measure, and then this also shows up the connection diagram, like your LEDs from here to ground and phototransistors between the sensor input and ground. Now, start the measurements. You can see it is making the measurement, and the time for one oscillation is something like 434 milliseconds. So, you clear this and do another set of measurements. You can do whatever number of times. If you want to measure 20 times, you just enter 20 there and say start that. So, we have seen now how the time measurement features of expeyes can be utilized to study electrical circuit as well as other experiments like simple pendulum. Like we wired a 555 oscillator circuit and measured its frequency and duty cycle, and also we measured the time period of oscillation of a rod pendulum.